Hello everyone, my name is Prakrit Krishna Shrestha. I am structural engineering student from Vellore Institute of Technology. Today I am going to design and analyze a tall building. This is for the project assignment for Skyfi Labs online course. So let me start by showing you the plan of the tall building. This building is not uniform throughout all the floors. So as we can see, from story 1 to story 8 we have this plan. All three bays have 6 meter in x-axis and y-axis, and from story 9 to 14 we have this plan. This is a bit irregular. Now for story 15 to 19 we have this plan, and from story 20 to 23 we have this plan. Some of the parameters used in these buildings are: all the dead loads are given as 2 kilonewton per meter square for all the floors, and the live loads vary in most of the floors. For story 1 to 18 we have 5 kilonewton per meter square as live load. For story 9 to 14 we have live load as 4.5 kilonewton per meter square. For story 15 to 19 we have live load as 4 kilonewton per meter square, and for story 20 to 23 we have live load as 3.5 kilonewton per meter square. Now for the beams and columns we'll use some different columns and beams. We'll assign the columns as 500 mm by 500 mm, 550 by 550 mm, 600 by 600 columns mm. And for beams we'll assign as 500 by 300 mm, 550 by 350 mm, 600 by 400 mm. So we will give input of all these beams and columns, and we'll use a property known as auto select property, so that while analyzing the building the software automatically selects the most economical building beams and columns. For the concrete we'll use M40 grade concrete, and for the rebars longitudinal reinforcements we'll use HYST 500 mm bars, and for shear reinforcements we'll use mile 250 mm. For all the slabs we'll be using 150 mm thick M40 grade concrete slabs. For the cladding walls we'll use a property known as auto draw cladding in ETABS, and we'll assign loads in all the exterior beams as 0.2 kilonewton per meter. For assigning the wind loads we'll consider the area as Bangalore, and all the parameters associated with that area will be considered. Now I'm using ETABS evaluation version. It is ETABS 18. So let me open a new model. The display units will be metric SI. Steel selection database will be Indian. Steel design code will be using IS 800 2007, and concrete design code will be using IS 456 2000. As shown in the plan, now number of grid lines in X direction will be 4, and similarly number of grid lines in Y direction will be 4. Spacings are given as 6 meter, so we'll change it, and in Y direction also spacings are given as 6 meter. And now for the story dimensions, number of stories is 23. Typical story height is 3 meter, and bottom story height is 3 meter as well. But we need to change some of the things in story dimensions, so we'll go to custom story data and go to edit story data. So as here we can see the master story is selected for story 23. It's given as yes. So now here we need to change master story for different stories so that we can make some similar stories. For example, story 1 to 8 has similar properties, so I can make story 8 as master property, and then select story 1 to 7 as similar to story 8. So base story remains, we don't need to change for base story. Now again for story 9 to 14, we can make story 14 as a master story, and then select all stories from 9 to 13 as similar to story 14. Okay. Now for stories 15 to 19, we can make story 19 as a master story and all stories below that as similar to story 19. Now again, yes, story 23 has already been set as master story, and stories 22 has already been assigned as similar to story 23. Press OK. Okay. Now our grid lines are ready. Now let us begin by defining the properties. First we'll define material properties. Go to add new property. The region, change it into India. Material type will do for concrete. Standard is Indian and grade is M40. Okay. Okay. Now again, we'll add new material. This time we'll change the material type to rebar. We have one as HYST grade 415. Okay. Okay. And another one is just change the grade to mild grade 250. Sorry, we need to change this as not this one. Yes, we need to change this as HYST grade 500. Okay. Now we have added three properties: M40 grade concrete, mild 250 rebar for shear reinforcements, HYST 500 for longitudinal rebars. Okay. Now we'll define the section properties. First of all, we'll define the frame sections. For this, we'll define for columns. Go to concrete. Property name, we'll assign this as column 500 by 500. Material will be M40 as mentioned before. So here depth we need to change 500 and width as 500. Now we need to modify and show rebar for reinforcements. Here it is selected as column. Okay. Longitudinal bars will be HYST 500 and confinement bars will be mild 250. Clear cover for confinement bars will be 40 mm for cover. It's okay. Okay. Again, new property. We can just do we can just do add copy of property, and here we can add as column 550 by 550. Okay, material is M40. Depth we can change as 550 and width also as 550. Reinforcement, everything is same. Okay. So two properties have been added. Again, add copy of property. So we can name it as column 600 by 600. Depth will be 600 and width will be 600. Reinforcement properties will be same. So okay, 3 columns have been defined here. Now what we need to do is we need to go to add new property and go to special. In special we can go to auto select list. Here in property name we can give the name as column auto select, and auto select design type will be concrete. All other, so these 3 properties we have defined, we can send it to here and then click OK. Now columns we have defined. Similarly for beams we can go to add new property. It's a rectangular beam, so here we can give name as beam 500 by 500. No, it's 300. Material is M40. Change depth as 500 and width as 300. And modifying show rebar reinforcement. Here we need to click for M3 design only beam. Longitudinal beam will be SYST 500 and confinement bars will be mile 250. So in cover we'll give the cover as 25 at top bars and 25 mm for bottom bars. Okay. Now we can we need to add new beam. For that we can go to add copy of property. Just change the name as beam 550 by 350. Material is M40. Change here as well. This will all be same. Okay. 2 beams have been added. Again, for third beam, it's beam 600 by 400. Okay. Here also we need to go to add new property and go to auto select list. Yeah. For name we can give as beam auto select. This will be concrete and all the beams will select and add here. Okay. Beam auto select is here and column auto select is here. Okay. Now we can do the modeling. Sorry, we need to define slabs first. So go to section properties and go to slab sections and new property. Slab, our slab is 150 mm slab, so we can give name as slab 150 for all the floors. Concrete will be M40 grade, thickness 150. Okay, slab is also defined here. Now we can go to the modeling part. First of all, here in plan view we are in story 23. We can go to story 1. Okay, story 1, and here we can select similar stories. For story 1 to 8 we have made a similar story, so we need to draw columns now. To draw columns, we can go to option quick draw columns. Here in property we can go to the column auto select that we had made, and all these columns we can model. So in 3D you can see for story 1 to 8 we have made the columns. Similarly, you can go to quick draw beams. Property will be beam auto select, and there are all beams throughout the plan. As you can see in 3D, beams have been created. Now for the slabs, go to quick draw this one, quick draw floor. Yeah, property will be slab 150, and select all the slabs. So in 3D you can see that for story 1 to 8 we have modeled beams, columns and slabs. Now we can go to story 9. Yes, and similar story is selected here. So here no beams and columns have been made and no slabs are there. Again we need to draw columns. We draw column auto select is selected. Yes. Now according to the plan as shown before, here for story 9 to 15 only there are columns in this part, no columns in this part. So we need to be careful. Okay, columns have been made here. Now for the beams, beams have been made. Now for the slab 150. Okay, now we can go to story number 15. Yes, column auto select. Okay, now for the beams, So now for slabs. Okay, now we'll go to story number 20. Columns are in this one. Let's see here. Okay, 6 columns are there. Yeah, and yeah, okay. Now for beams. Beam auto select. For the slabs. Okay, I think our modeling has been completed. Now we need to assign loads. So let's go to story number 1. In story 1, we can select all these slabs. We should go to all stories. Go to all stories and select all the slabs. So all the slabs have been selected. First we'll assign dead loads. Go to assign, shell loads, and then uniform. Load pattern is dead load. Since dead load is 2 kN per meter square for all the slabs throughout all the floors, we'll apply this load. Okay. Now you can see that for all floors, not in base slab, top floors, all floors, we can see that load has been assigned as 2 kN per meter square. Okay, now we need to assign live loads. For that, live load is different for some different stories. So for story 1 to 8, I think live load is given as 5 kN per meter square. So now here we need to go in similar stories and select the slabs of first floor. Assign shell loads uniform as, no, we need to change this as live load and go to load as 5 kN per meter square. Apply. Okay. So from story 1 to story 8, 5 kN per meter square has been assigned. Now go to story number 9. Okay, similar stories is selected. Select all the slabs and assign shell loads uniform live. Now here it will be 4.5 kN per meter square. Apply. Okay. Go to story number 15. select all these slabs, assign shallows uniform. Now the live loads given here are 4 kN per meter square. Apply. Okay. Now go to story number 20. Yes, select these two slabs, assign shell loads uniform. The load here is given as 3.5 kN per meter square. Apply. Okay. Again, now we need to assign the loads from the walls, the cladding walls. So go to story 1 and select all the exterior beams here. This is just for story 1 to story 8. Okay. Only this up to story 8 exterior beams have been selected. Now go to assign and then frame loads, and then distributed. Load pattern name will be dead load and load will be 0.2 kN per meter. Okay. You can see here the loads has been assigned as 0.2 kN per meter. Now for stories 9 to 14. Stories. Okay. Story 9. Now we'll go to story 15. Now for stories from 20 to 23. So the dead load, live load and frame loads of cladding has been assigned. Now what we need to do is for story 23. For story 23 there won't be any loads of cladding. So we need to remove these loads. delete existing loads, apply. Okay, now we need to go to base story. Here no slabs has been assigned here, but what we need to do is select all the joints. 16 joints have been selected and assign the joint distance as fixed, apply. Okay, now all the joints in the bottom has been assigned as fixed joints. Now to draw the cladding walls, we'll use the property draw, and then there will be a property known as auto draw cladding. Okay, select use floors. Okay, so the cladding walls have been drawn here. Now we have assigned dead load, live load and cladding wall loads. Now we need to assign a special load of wind load. Assign. First of all, we need to define in load patterns. Here we need to name the load as wind. Type will be wind. Self multiplier will be 0, and here the code will be IS 1875. Add new load. Okay, so for this load we need to modify the lateral load. Here we can see according to the IS 1875 part 3, and the area we have taken as Bangalore. So in IS code we can see that wind speed for that area is 33 meter per second, and according to clause 5.3.2.1 you can see the terrain category. Terrain category is defined as 3 there. The structure class is defined as C according to IS code, and for the risk coefficient factor and topography factor, since we have designed the building for 50 years design period, so risk coefficient will be 1, and according to slope of the building, topography will be 1 as well. Other things we don't need to change now. Okay, this has been defined. Okay, now we need to go to elevation. We can select section A of elevation. Okay, so this is the A section elevation. We need to provide wind load in this. This is the windward direction. We need to provide wind load in this direction. So first of all, select all the cladding tiles. Okay, all cladding shells have been defined. Now in the IS code you need to see in table 4 H by W is shown there. So our H by W is height is 69 meter and width is 18 meter. So our H by W will be 3.83, and L by W length by length is 18 meter and width is 18 meter as well. So 18 by 18 is equals to 1. We'll get L by W as 1. So in this category you can see that in the windward direction you have coefficient as 0.8 wind pressure coefficient, and at B direction you have wind pressure coefficient as minus 0.25, and in direction C and D you can see wind pressure coefficient as minus 0.8. So what we need to do is the section A here will have wind pressure coefficient of 0.8. So go to assign and then shell loads and go to wind pressure coefficient. Here coefficient will be 0.8. This according to the IS code, and the direction will be windward. Okay. So again in elevation we need to go to B elevation, right? Okay. So here also the wind coefficient will be 0.8. Go to assign shell loads pressure coefficient 0.8, apply. Okay. Now for elevation D and C, right? Okay. For the elevation of D section, in IS code it is shown as B section. This is a leeward side and it has wind pressure coefficient as minus 0.25. So assign shell loads wind pressure coefficient as minus 0.25 and this will be leeward. Apply. Oh sorry, I did not select the slabs. Okay, assign minus 0.25 leeward, apply. Okay. Also in elevation of C, 0.25, apply. Okay. Now in elevation go to section 1, apply. Okay. Here the coefficient is minus 0.8, is shown in C section and D section in IS code table 4. Select all the panels. So also for another direction we have pressure coefficient as minus 0.8. So you can move up in list here, and this is 2 elevation, elevation 2. Here also you can select. Also in 3. And also in 4. Okay, now assign wind pressure coefficient minus 0.25 will be changed to minus 0.8. Direction is leeward. Apply. Okay. So now wind load has also been applied. We can again go to plan view. Okay. As you can see, I think here one road is missing. .8 has to be assigned here. Yeah, in this direction road is missing. So elevation BB, elevation B, apply. Okay. And here assign. You know what? Plan. Now here load has been applied. So wind load has been applied in all the floors. Now we can go to analysis part. First of all, what we can do is in the 3D view, we can use this, use extruded view for frame objects. So that some rendering has been done here. Now we'll go to analysis part, go to analyze and do run analysis. We need to save this file. So I'll be saving here as tall buildings. Tall buildings. Tall building. Analysis. Save. It will take some time to analyze. So some deformed shape you can see here. Now you can go to design part, design, steel concrete frame design, view device preferences. Your design code is selected as IS456-2000, so it's okay. Again go to design, concrete frame design and do start design check. Analysis and design sections differ for 705 concrete frames. Do you want to reiterate analysis and design? This means that the least section of columns 500 by 500 and beams 500 by 300 were used at first, but since some sections didn't pass, I mean 705 sections didn't pass, they want to increase the section size. So if I select yes, the ITABS will reiterate again and choose for higher sections. So I did yes. This will again reiterate. Analyze and design section default for 10 concrete frames. Again we will reiterate and it will choose for higher columns and beams. I mean 600 by 600 and beams 600 by 400. Now you can go to design, concrete frame design, and see if all the members have been passed. Verify all members passed. All concrete frames passed the design check. So all our members have been passed. Now for the detailing part, since this is ETABS 2018, we don't have detailing option yet. We need to use CSI detail for it. To see any of the properties, you can go to here and you can see all the properties. If you want to see the project report, go to reports, summary report. ETABS creates the project report, and you can see all the details here of all beams, columns, slabs, all the loads transferred. So by this we come to end of design, analysis and detail of tall building. Thank you.